Hi, and welcome to the skill of simplifying rational expressions. So for this problem, we're going to be working with 6x cubed minus 14x squared minus 40x divided by x to the fifth plus 3x to the fourth minus 28x cubed. So take a moment, make sure you have that written down so that we can, as we go through this process, you can follow along. And again, pause the video when you need to, rewind if you need to. Here we go. So when we're simplifying, and throughout this unit, it's been really important to factor. So we want to see, where can we factor? Factor first. Factor always if possible. So I'm going to look at the numerator first. And I kind of notice every single term there has something in common. So the GCF looks like each term is divisible by a 2. And also each term is divisible by an x. So this I can change into 2x comes out of every term. 6x cubed divided by 2x would leave me with 3x squared. And if I multiply those together, I notice I get back to 6x cubed. And negative 14x squared divided by 2x would leave us with a negative 7x. And a negative 40x divided by 2x would leave us with a negative 20. Okay, so I've taken care of the GCF in the numerator. The quadratic factor that's left there looks a little bit more complicated to factor, so I'm going to pause on it for a moment, and I'm going to focus on the denominator for a second. And so if I look here, the GCF, every coefficient doesn't have a factor in common, but each term still does have, it looks like the largest number of x's each term has in common is 3, so x to the third. So I'm going to pull x cubed out, and if I do x to the fifth divided by x cubed, I'm going to be left with x squared. 3x to the fourth divided by x cubed, I'm going to be left with 3x. And then a negative 28x cubed divided by x cubed, I'm going to just be left with a negative 28. So I've factored out the GCFs from both the numerator and the denominator. These quadratic factors that are left, the one that's a little bit easier for me to factor is definitely this one. And so I could kind of notice, that the leading coefficient is 1 on the quadratic, always easier. So I'm going to keep the x cubed. But I want to think about like what multiplies to be a negative 28 and adds up to be 3. So that's x plus 7 times x minus 4. Now, this is a game of simplifying, and so sometimes our goal is to cheat the system. Like I'm now going to come back up here to the numerator, and I'm going to think, I do know that there's going to be a 3x. 3x is prime, or 3x squared is, the 3 is prime. So I've got 3x, and over here I know I'll have an x. Now, because we're simplifying, we probably want one of those factors from the denominator to be up in the numerator. Well, 7 doesn't divide into 20, but 4 does. So I'm going to just kind of say, like, what if one of the factors was x minus 4? Sometimes what's great about this simplifying is we know we probably want something to cancel, so we can kind of always find where it's easiest to factor, and then through guess and check, maybe see if something else happens. Now I know 3x times x is 3x squared. The 3x times the negative 4 is a negative 12x. I need to get to a negative 20 though. So a negative 4 times 5 would get me a negative 20. So that needs to be positive. Well, I've got 5x now, and I've got a negative 12x, and those do combine to be negative 7x. So through kind of a game of guess and check, we have the correct factorization. Oops, sorry, that got deleted there. So this is how the numerator has factored and how the denominator has factored. Now is the fun part where we get to start canceling factors that are in both the numerator and denominator. And so we do notice that the factor of x minus 4 is going to get deleted or canceled down to 1. The 3x plus 5 will not cancel, and the x plus 7 won't. The 2, there's no coefficient out front, so the 2 is just going to stay. But what we might want to think about is this x and the x cubed. X cubed is x times x times x. Well, one of those x's up top can cancel out with one of the x's in the bottom, and so we'll be left with x squared down below. So we've got, if we look at what's remaining and what has not been canceled out, we have a 2 times the quantity 3x plus 5. Then nothing else is left up in the numerator. In the denominator now, the x cubed, again, one of the x factors got canceled, so we're left with x squared, x times x, and then we also have x plus 7. And this is what the fraction simplifies into. Now, if you were asked about restrictions, we should kind of come back and look at what happened before we simplified. Back at this moment, we definitely want to say like, well, x could not have equaled 0, because that would make the denominator 0. X could not equal a negative 7. And the factor that got canceled right here was in the denominator. X could also not have equaled 4. So sometimes we didn't ask for it in our review. However, if it were to be asked for on a quiz or a test, you would always want to make sure, or on an SAT or ACT type question, you just want to make sure you do reference what the values of x could not be. So I hope that this has helped you with simplifying. Really think about how important it is to factor. Always be on the lookout for a greatest common factor, the GCF. And then thinking about how you can factor quadratics. And sometimes pick the location that's easiest first. And then through maybe backward thinking, you would be able to factor maybe a harder location. Good luck with the rest of your review.